Okay, guys, moving on here with more probability. You guys are doing great. Keep up the good work. Uh, we've got 2 more weeks of lessons here, and then you got your exam, and then you'll be done here. So we're kind of getting close here. So this is lesson number 11 we're on, which is going to be probability trees. We're going to go a little more advanced with probability trees. So we'll call it probability trees 3. Okay, these will be the most advanced ones you see. Okay, so I'll just give you 3 examples that relate to the ones on your homework. You flip a coin 3 times. Okay, for all these I'd recommend draw them pretty big so you got room, because they're going to be a little more complex, so you need room to show all the results. So notice I did heads tails, off of that heads tails, and off of each of those heads tails. So it gets a little bit complex. I don't need to put any numbers on this because everything's equally likely to happen as far as heads tails. You could put a half and a half on this, but it's not necessary. Okay, so here's the results that we're seeing: HHH, HHT, HTH. I'm just following the path. HTT. These are all the different things that could happen. THH, THT, TTH, and TTT. Okay, so it'll say something like, what's the probability of getting 3 tails in a row? 3 tails, like this. All right, so you just say, okay, well, it's just right here. It only happened once. There's 8 possibilities here, right? 1, 2, 3, 4, 5, 6, 7, 8. So 1 out of 8. What's the probability of getting 2 heads and a tail? And it's generally always in any order, okay? In other words, it could be two heads and a tail like this. Could be 2 heads and a tail like that. There's one. 2 heads and a tail there. And it looks like those 3, so 3 out of 8. All right, so that's pretty straightforward. It's just drawing a bigger tree. Okay, next one, you'll see something where you gotta be a more complex marble problem. So let's say there's 2 red marbles, 3 oranges, and 4 yellow. Okay, you're going to draw 2 without replacing. So I'll draw 1, draw another one. I won't replace. Okay, so again, make this tree pretty big because you got 3 choices here. Red, orange, yellow. And then on the second pull, you're going to have red, orange, yellow again on each. So draw it big. It might take up most of your paper to do one of these drawings, honestly. But there's not too many. You only got to do 3 or 4 problems. Okay, so that's the setup. Put the probabilities on. We can't just keep it like this because it's not the same chance for each thing. So for red, it's a 2 out of, there's 9 marbles total, so 2 out of 9. Orange is 3 out of 9. I would reduce that to 1/3. Yellow is 4 out of 9 chance. Okay, on the second pull, since I'm not replacing, there's only 8 marbles left. I pulled a red here, so there's only 1 left out of 8. There's still going to be all 3 oranges left out of 8, and still all 4 oranges left out of, all 4 yellows. Reduce that is 1/2. Okay, and then same thing going down. Say I picked an orange. All the reds are left. 2 out of 8. 1/4. One of the oranges gone, so that's also 2 out of 8, correct? Gets a little bit squishy here. And then yellow, all 4 are left out of 8. Well, it's actually just half of them. Okay, and then say I pulled a yellow. There's 2 left out of 8. Oranges, there's 3 left out of 8. And yellow, since I drew one, there's 3 left out of 8. Okay, to find the probability of each of these branches, you multiply. So red is going to be 2/9 times 1/8. Okay, let's just write down the outcomes, and then we can use that to answer some questions to save us a little bit of time here. We don't have to do all the math out. Orange, yellow, and then we got yellow, red, and yellow, orange, and yellow, yellow. Okay, so the question might say, what's the probability of, I'll put over here, what's the probability of getting one orange and one red in either order? Okay, so one orange and one red in either order. So let's go down and find those. Here's an orange red. Let's find the probability of that. It's actually red orange, but 2/9 times 3/8, right? We're talking 6. 9 times 8 is 72. Reduce that. We're talking 1/12. Okay, let's look for some more orange red. So right here's one. 1/3 times 1/4 is 1/12. Okay, so we got that one, and then down here, probability of there's a red, orange. No, actually no. Sorry, it's just those two. So we've got those two. You really need to add those two together. I didn't really say that last time, but you should add those together if there's more than one way to do it. We multiply through here, but then we add at the end if there's multiple ones to add. So we're talking 2/24. I'm sorry, 2/12, which is a 1/6 chance. Okay, so the probability of getting an orange or red in either order is actually 1/6 because there's a couple ways to do it. Okay, so just be careful of what the question asks you and then use that branch, those branches of the tree. But to figure out the probability of any of these branches, you just multiply down. Okay, just multiply down that path. Okay, hopefully that makes sense. And then the last one you'll see, guys, is, I won't go through all of it, I'll just give you the setup here. It's flipping a dice, 6-sided dice, 2 times. Okay, not flipping, you probably say roll. Roll a dice 2 times and add it. Okay, that's what we normally do. Add the results when you're playing a game, right? You don't roll two dice and then you add them together. Okay, again, draw this big because what's going to happen is there's going to be 6 branches off of each of these. Okay, which honestly I didn't even draw it big enough. It gets quite messy. But you know what I'm saying, there's got to be 6 off of each of these, and then that will be the tree that you're going to use. I guess we got her on there, but on this one, again, because everything is equally likely, you don't need to put the fractions on here and stuff. You can just make this up. I guess we'll answer one quick question on this since we got her drawn up. This would be the tree. So say, what's the probability of sum of, let's say 3. Okay, we got to look all the ways to get 3. I mean, there's actually 36 results here, right? 1, 1, 1, 2, 1, 3, 1, 4. If I went down all these results, we got 6 times 6 is 36 results. Getting a sum of 3, well, that would be a 1 and a 2 here, right? So this would be one result. That would give me a sum of 3. Also here, 2 and a 1. Give me a sum of 3. So there's 2 of those branches out of 36 total that give me a sum of 3. So we're talking a 1/18th chance. Okay, hopefully you guys get all that. That one's, you know, there's not too many of these problems that do because they do take a while to draw out the trees.